again, following this formula right here, we're now going to say, instead of calling it the slope of the tangent, because the slope of the tangent is at a particular point, all right, say find the slope of the tangent in general, now it'll be find the derivative. So we're going to use that same formula to find, I showed Pascal's triangle this last year. Like we already hit this a while ago. What? I'll bring you guys a handout on it because you're going to, like, for this section, it's super useful. All right, so we want to find f prime of x. You're in physics, you already know what it is. What's our final end goal, kids?
3x squared.
Yes, so that's what we're hoping to get to. So using that idea, f prime of x is now the limit as h approaches 0. Instead of calling it that a, where we're plugging in a number for a, we're going to keep it the general x. So it'll be x plus h cubed minus x cubed all over h. This is where Pascal's triangle comes into play. So these are coefficients of 1. So Pascal's triangle says, maybe this will help kind of recall it. It goes 1, 3, 3, 1. Because you add up the sums of the rows before. So a cubic would live on the third row. So you'd add them together, so you get 3 in the middle, 3 in the middle, and 1s are always on the outside. So it's going to go 1, 3, 3, 1. And then what you're going to do is you're going to take the variables, and the powers are going to go down for one variable and go up in reverse for the other. So what that means is this is going to go 1, 3, 3, 1. You start with the x being this power here. So it goes x cubed, x squared, x, and then x to the 0, which is 1. Does that make sense so far?
Yeah.
Take the second variable, which is h, and it goes in reverse. No h to the first, h squared, h cubed. Ran out of room. Always plus size between them for Pascal's. If that were a minus, the signs would alternate. Because if you think about when you multiply things together, we'll go positive, negative, positive, negative. So that represents this, and then we tag along our minus x cubed all over h. So what cancels? Beginning and the end. Do they each have an h? Gone. So that becomes to the first, that becomes to the second. So now I'm left with the limit as h approaches 0 of 3x squared plus 3xh plus h squared. We plug in our 0. (3x squared). Definition of the derivative. We have a new way that we can look at the derivative at a point. So in the past, we've been doing it as f of a plus h minus f of a all over h. Well, what we can actually do now is manipulate that formula to look at or approach at a value a instead of going to 0. So we have another way that we can talk about the derivative of a function at a particular point. So we can say f prime of a, so the derivative at point A, is equal to the limit as x goes to a, instead of h to 0, you do generic f of x and x minus f of a at a. So it's a manipulation of this. We're going to plug it in and do it this way too, okay? I like doing it like this.
So we don't have to do it that way though if we don't want to?
No.
There's just another option.
Yes. We'll do one example like it, and then I'll probably go back to my other one because I'm not a huge fan. Mainly because now you kind of like have to factor. To get x minus a to cancel, you have to like factor. Yeah. So I said I show it. It's easier with numbers because like things go away. But yes. So you almost have to like set up factor by grouping to like make it work out a little bit nicer.
That is weird.
That's what I said, like I
You
just,
have to like pull out -8 out of the 1, but then you have to take the squared out of the 1 and stuff like that.
yeah. Like I try to look at it like this, because I think it's a little easier to see.
Oh, but isn't, like, if you combine x squared minus a squared, can't you just make that 2 times x minus a because, or not 2 times?
No, because that would be x minus a squared.
Squared.
Which you could. So
You have to,
so your brain wants to go.
you have to do it, and then if you do it plus of it though, because aren't they different, so you can do plus and minus. You can do x minus a and then x plus a.
But you don't have it over here now. You'd
Yeah,
have
but
to
if you-
GCF out your 8. Yep.
Yeah, if you pull out the 8,
So
that
keep
would
going.
give you with x minus
You
a.
did it so goofy.
And then you just cancel.
Wait, that becomes positive.
No, it becomes negative because it's
Negative.
If you
Did
pull
I?
out-
Oh, I copied it down wrong. I lost this sign. There we go. I did it a different way, but this works.
and then
So do you see what he did? So we rearranged. We pulled the a squared in front.
Well, I just have a question.
Go ahead.
Like, from the first line, would you be able to factor, like, just the 2 separate quadratics right off the bat, or do you have to, like, combine them?
So factoring them right off the bat won't help you with the denominator because this would have x's and this would have a's. So you have to group them. It's just a matter of how you want to group them. So we thought differently. I flip-flopped them. I put the 8x with the a like over there and the a over here. So then I can take out, like, I grouped these two, factored out an f, and a, x, and left myself with x minus 8. And I did over here and left myself with the -8. But this works so too, and I've never seen it done this way, and I like it. So he said, okay, x squared minus a squared is a difference of squares. So Dom grouped the first and the last two together and kept the middle terms together. And then said x squared minus a squared is x minus ax plus a. Still have not broken any laws of algebra. We're doing factor by grouping. Over here, these two have a GCF of -8. So let's take a -8 away. So now, this has an x minus a, and this has an x minus a. So by laws of algebra, I can take an x minus a out because I could ultimately distribute it back in. So if I take it away, that leaves x plus a minus 8. Again, you could distribute it back in. Go ahead.
then they cancel,
And then those two cancel, yep. So now you don't have the a in the denominator as an issue. You get the limit as x approaches a of x plus a, that really hurt, minus 8. What do you do when you get down to this point? Usually with the h, we plug in a 0, so now we plug in a,
which leads you to a minus 8, which is does support the power rule.
does. It's just, I feel like it's, like this algebra is so much harder.
I didn't take it out because I just saw that there were ones on both sides, so I just canceled because it's a negative. So if they're on the same side, you can pull it out.
I got you. Like
Instead of-
instead of treating it like a
Yeah.
GCF.
Instead of like trying to group it all weird and do that, I just canceled each sides out, which will leave you with x plus a minus 8 with nothing. Because you have it on both sides of the negative, so then therefore you can pull it out since it's divided by that bottom.
Did you write it down?
Huh?
Did you write down what you're saying to me?
Do you want me to?
Kind of. I kind of want to see what you're trying to say.
Because it's x minus a times x plus a.
Yeah.
And then that's the whole thing minus 8x minus a. And that's all over x minus a at this point. Both sides of the negative, there's two terms on each. One's 8 times x minus a, and one's x minus 8 times x plus h. So then, since the bottom's an x minus h, you can just cancel one from each side. 'Cause if you
Okay,
treat
I
that
get
as
what
a
you're saying.
variable,
Like you're saying if this was like
if you treat that as like a
6x
y,
squared minus, I don't know, 6y all over.
6,
Yeah,
Then
you
you
went like
cancel.
that. Okay.
instead of trying to.
I just treated
Yeah.
it. I just feel like that's like, you know what I mean? Like I took out my DCF
Yeah.
to prove how you could cancel it. I got you. Still, I just like the a plus h so much better.
I mean, it still combines because it's the same, so you can just put them together and try.
We'll do it for this problem, but we'll do the limit as x approaches a, but let's pick a number.
For what? This?
So, yeah, so let's pick a is equal to 4. So instead of doing it as the general a, let's do it as x equals 4. Like we'll say that. So we're going to do the same thing. What?
We're gonna do this still weird.
As x approaches 4 of f of x, so it'd be x, I'm going to write a square root, minus, it'd be the square root of 4 all over x minus 4. Does that make sense? F of x, x, minus f of a, where a is 4. What?
Take a different square root.
Yeah, you're going to multiply by the complex conjugate.
1 over the square root of square root x plus square root 4.
Don't let you so enthusiastic.
And then you plug it in, so it's 1 over 4.
I didn't ask you to keep talking.
You're hurting their brains.
Sorry.
So,
Trying to learn.
so again, anytime you have that square root and you're trying to get rid of it and cancel a denominator, complex conjugate. We know square root of 4 is 2, so let's make our math a little easier. Get rid of that thing. Square root times square root become x. The middles are going to cancel because it's the complex conjugate. A negative times a positive is a negative, and 2 times 2 is 4. And if you'd have left it the square root of 4 times square root of 4 is 4. Don't FOIL factor or do anything with your denominator, because look at the beauty that just occurred. As I said, it's not bad when a is a number. It's bad when a is a what? When a is a number, this process is kind of nice. All good. Jump the gun.
If you would just left it as that, would the answer have been 1 over 2 square roots of A?
Yes. If it was in general. Go ahead. Yes.
So for this, don't we have to do the x plus h?
This is the new formula.
This is this formula.
Oh. Okay.
So I did f of x at the beginning, right?
I
So
was
here's,
confused there.
that's okay.
This one better.
Here's the f of x and the x.
Yeah.
Here's the f of a and the a. This one is really nice when you know what a is.
It's not so nice when you don't.
It is not exactly, it is not so nice when you don't know what a is.
was. Okay.
Because this one, if I didn't know what a was, not that this one still isn't kind of messy the long way, because you have x plus h squared, then you have to distribute an 8, then you, but I definitely think this one in particular, and some of the other ones are easier with plus h. Your homework this weekend is, I have the same slide twice, is to simply continue to practice this. So I have a handout, and Dom, you'll like it because it kind of leads into the power rule. So the first 2 are linear, then the next 2 are quadratic, and then like you kind of see how the power rule applies using the definition of the derivative now. So we are officially looking at derivatives. We are applying our definition. Oh, yeah, sorry, girls.
What?
I gave them this period too because I felt bad that they were sitting and so I said, hey, start your homework. Because I knew that they knew how to do the limit.
I'm just saying the answer's wrong, right? You get it, you can do it.
I like the second equation better, to be honest.
When you know a number.
I still don't think it's bad.
Really? You can do your homework using it. Oh my god. But again, it's each their own, right? Like, we all